Good morning, everyone. In this particular video lecture, we will discuss the previous year objective questions of paper 1 of SSJ of the subject named Basic Electronics of the topic Semiconductor Physics. Now, the first question is the temperature coefficient of an intrinsic semiconductor. ठीक है, तो ये पहला क्वेश्चन है और ये जो है SSJ 2010 में पूछा गया है. ठीक है, तो इसका जो करेक्ट आंसर होगा ऑप्शन सी होगा, डेट इज नेगेटिव. ठीक है, तो इसका जो करेक्ट आंसर होगा क्या होगा, ऑप्शन सी, डेट इज नेगेटिव. नाउ जो सेकंड क्वेश्चन है हम लोग का, विच ऑफ द फॉलोइंग मटेरियल इज सेमीकंडक्टर. इसमें कौन सा जो मटेरियल है सेमीकंडक्टर है. ये जो है एसएससी जेईई 2012 में जो ये क्वेश्चन पूछा गया है. ठीक है, तो इसका जो करेक्ट आंसर होगा ऑप्शन बी, डेट इज सिलीनियम. ठीक है, इसका जो सिंबल होता है एसई होता है, जिसको कि हम लोग फोटो कॉपिंग मशीन और फिर फोटो सेल्स जो होता है उसको बनाने में हम लोग यूज करते हैं. ठीक है, तो इसका जो करेक्ट आंसर होगा वो ऑप्शन बी होगा. ठीक है, जिसको हम लोग सिलीनियम बोलते हैं. ठीक है, जो नेक्स्ट क्वेश्चन हम लोग का, अंडर थर्मल इक्विलिब्रियम इन सेमीकंडक्टर द रेशियो ऑफ नंबर ऑफ होल्स टू द नंबर ऑफ कंडक्शन इलेक्ट्रॉन इज, ऑप्शन सी इसका करेक्ट आंसर होगा 1. क्योंकि क्या होता है कि अंडर थर्मल इक्विलिब्रियम में क्या होता है कि नंबर ऑफ इलेक्ट्रॉन एंड नंबर ऑफ होल जो होता है क्या होता है, इक्वल होता है. ठीक है, जिसके कारण रेशियो क्या हो जाता है, 1 आ जाता है. ठीक है, तो इसका करेक्ट आंसर जो होगा ऑप्शन सी होगा, डेट इज 1. और ये जो है एसएससी 2012 में पूछा गया है. ठीक है, तो देखिए फोर्थ क्वेश्चन जो है, फॉर एन टाइप सेमीकंडक्टर के लिए जो डॉपिंग मटेरियल होता है वो क्या होता है, वो पेंटावैलेंट होता है. ठीक है, तो इसका जो करेक्ट आंसर होगा वो क्या होगा, ऑप्शन बी, डेट इज पेंटावैलेंट. नाउ द नेक्स्ट क्वेश्चन इज in a semiconductor the resistivity, its correct answer will be option A, that is depends upon temperature. ये जो क्या होता है कि जो रेसिस्टिविटी होता है सेमीकंडक्टर का वो क्या होता है, टेम्परेचर पे डिपेंडेंट, टेम्परेचर पे क्या करता है कि डिपेंड करता है. ठीक है, तो इसका जो करेक्ट आंसर होगा वो क्या होगा, ऑप्शन ए होगा. चलिए नेक्स्ट क्वेश्चन क्या है कि सिलिकॉन हैज़ अ प्रेफरेंस इन आईसी टेक्नोलॉजी बिकॉज. ठीक है, तो इसका जो करेक्ट आंसर होगा क्या होगा, ऑफ द एबिलिटी ऑफ नेचर ऑक्साइड SiO और SiO2. ठीक है, तो इसका जो करेक्ट आंसर होगा वो क्या होगा, ऑप्शन बी होगा. क्योंकि क्या होता है कि बहुत सारा यहाँ पे मेन जो उसका रीजन होता है ड्यू टू फॉर द प्रेफरेंस इन आईसी टेक्नोलॉजी, बेसिकली उसका जो होता है क्या होता है कि लोअर लीकेज करंट होता है. ठीक है, उसका जो क्या होता है लोअर लीकेज करंट होता है. लेकिन यहाँ पे जो अभी ऑप्शन दिया हुआ है उसमें सबसे जो बेस्ट अगर हम लोग देखें करेक्ट जो होगा क्या होगा, बी होगा, ऑप्शन बी, डेट इज ऑफ द एबिलिटी ऑफ नेचर ऑक्साइड SiO और SiO2. ठीक है, नेक्स्ट क्वेश्चन बेसिकली क्या है, टू प्रिपेयर अ पी टाइप सेमी कंडक्टिंग मटेरियल impurities to be added to silicon are, ऑप्शन बी इसका करेक्ट होगा, डेट इज बोरॉन एंड गैलियम. ठीक है, इसका जो ऑप्शन बी क्या होगा, करेक्ट होगा, बोरॉन एंड गैलियम. नाउ द नेक्स्ट क्वेश्चन इज इन एन इंट्रिंसिक सेमीकंडक्टर. ठीक है, इंट्रिंसिक सेमीकंडक्टर में जो है ये कौन सा ऑप्शन जो है बेसिकली कौन सा ऑप्शन जो है सही है. ठीक है, तो यहाँ पे देखिएगा तो ऑप्शन बी जो है नंबर ऑफ होल्स इज इक्वल टू द नंबर ऑफ इलेक्ट्रॉन, ये जो ऑप्शन है क्या है, करेक्ट है. ठीक है, तो इसका जो करेक्ट आंसर होगा क्या होगा, ऑप्शन बी होगा, डेट इज नंबर ऑफ होल्स इज इक्वल टू द नंबर ऑफ इलेक्ट्रॉन्स. Now the next question is, the minority carrier concentration is largely a function of, its correct answer will be option B, that is temperature. Now the next question is, in the depletion region of a PN junction there are dash, its correct answer will be option B, that is no mobile charges. Now the next one is, that is the donor atom in an n-type semiconductor at normal temperature. At normal temperature, its correct answer will be option A, that is carries a positive charge. Its correct answer will be option A, that is carry a positive charge. Now the next question, that is Fermi energy level for p-type extrinsic semiconductor. Its correct answer will be option C, that is close to valence band. That is close to valence band. And position, if we talk regarding the position of Fermi level in a p-type semiconductor, that is basically close to valence band. Now similarly if we talk for n-type semiconductor, Fermi level is nearer to conduction band, and for an intrinsic semiconductor if we talk, then it lies in the middle of valence band and conduction band. Now the next question is 30 number, that is considered a single crystal of an intrinsic semiconductor. The number of free carries at the Fermi level at room temperature. Its correct answer will be option B, that is half the number of free electrons in the crystal. Now the next question, that is 30 number, that is 40 number. A semiconductor is formed by dash bonds. Its correct answer will be option B, that is covalent bond. Now the next question, that is 15 number. Resistivity of a semiconductor depends on. Its correct answer will be option D, that is the atomic nature of the semiconductor. That is the atomic nature of semiconductor. If we talk regarding its explanation, then resistance depend upon length, area of cross section, volume, but resistivity of a material basically depends upon its crystal structure and atomic nature. So its correct answer will be option D, that is the atomic nature of the semiconductor. Now the next question, that is 16 number. A germanium atom contains, okay, so its correct answer will be option A, that is 4 valence electron. As we know, atomic number of germanium is 32, valence electron is 4. Now the next question, that is 17 number. A hole is the vacancy created when an electron breaks its covalent bond. Its correct answer will be option B, that is an electron breaks its covalent bond. Now when electron breaks its covalent bond, then both hole and electron pair are generated. Now the next question, that is 18 number. Forbidden energy gap between valence band and conduction band is least in case of impure silicon. Its correct answer will be option D, that is impure silicon. Now the next question, that is 19 number. Donor impurity atom in a semiconductor result in. Its correct answer will be option C, that is discrete energy level just below the conduction level. Now the next question, its correct answer will be option C. Now the next question, that is 20 number. A p-type semiconductor is electrically neutral. Its correct answer will be option C, that is electrically neutral. If we talk regarding its explanation, then the term N and P doped do refer to majority charge carrier. Each positive and basically negative charges carrier belong to a fixed negative or positive dopant. So p type material is mainly positive charge carrier, but it has an acceptor which is negatively charged, so overall semiconductor is neutral. Now the next question is 21, that is change of carrier concentration along with length of a semiconductor is called concentration gradient. If we talk regarding concentration gradient, then we will it means basically charge carrier moves or as we know, charge carrier moves or diffuses from higher concentration region to lower concentration region, and excess carrier generation is non-uniform. So diffusion current mechanism can also be expressed as we can call it as concentration gradient, that is dN by dx. In other words, we can also say that rate of change of concentration with respect to distance is called concentration gradient, and it is we can denote it as dN by dx. So its correct answer will be option C, that is concentration gradient. Now the next question, in a semiconductor, movement of charge carries under influence of an electric field is called drift. Its correct answer will be basically drift, and drift is current due to electric field, that is due to potential gradient dV by dx. So its correct answer will be option B, that is drift. Now the next question, that is 23, in pure silicon, major part of the drift current is due to free electron, because its correct answer will be option C, that is mobility of electron is greater than mobility of holes. Its correct answer will be option C, that is mobility of electron is greater than mobility of holes. Now the next question, that is 24, semiconductor may be made N type by adding donor impurity. Its correct answer will be option C, that is during crystal pulling. During crystal pulling. Now during crystal pulling, semiconductor may be made N type by adding donor impurity. Now the next question is basically Fermi energy level for N type extrinsic semiconductor. N type extrinsic semiconductor n-type extrinsic semiconductor lies? Its correct answer will be basically option B, close to conduction band. Its correct answer will be option B, close to conduction band. Now the next question, that is 26. The diffusion potential across a p-n junction. Option A is decreases with increasing doping concentration. Option B is increases with decreasing band gap. Option C is does not depend on doping concentrations. Option D is increases with increase in doping concentration. Its correct answer will be option D, that is increases with increase in doping concentration. Now the next question is 27. Now the next question 27, that is in germanium, when atoms are held together by the sharing of valence electrons, which of the following is correct? Option A is each shared atom leaves a hole. Option B, valence electrons are free to move away from the nucleus. Option C, valence electrons form irreversible covalent bonds. Option D, valence electrons form reversible covalent bonds. Its correct answer will be option D, that is valence electrons form reversible covalent bond. Although as we know, by sharing of electron, covalent bond will form between the atoms of germanium, but this covalent bond can be broken when thermal energy is supplied, hence reversible in nature. Now the next question is 28, that is in a pure semiconductor, electric current is due to. Its correct answer will be option C, that is both holes and electrons. That is both holes and electrons. Now the next question, that is 29. Temperature coefficient of resistance in a pure semiconductor is negative. Its correct answer will be option C, that is negative. Now the next question is basically accepted impurity atom in a semiconductor result in nu. Option A is wide energy band. Option B is narrow energy band. Option C is discrete energy level just below conduction level. Option D is discrete energy level just above valence band. Its correct answer will be option D, that is discrete energy level just above valence level. Now the next question, that is 31 number. An n-type semiconductor has. Its correct answer will be option C, that is electrically neutral. Now the next question, that is 32. When a free electron is recaptured by a hole, the process is known as recombination. Its correct answer will be option A, that is recombination. Now the next question, imperfection in the crystal structure results in. Option A is increased conductivity. Option B is decreased conductivity. Option C is increased mobility. Option D is decreased mobility. Its correct answer will be option B, that is decreased conductivity. Now the next question, 34 number. At room temperature, intrinsic carrier concentration is higher in germanium than is silicon because option A is carrier mobilities are higher germanium than in silicon. Energy gap in germanium is smaller than in silicon. Atomic number of germanium is larger than silicon. Option D is atomic weight of germanium is more than silicon. Its correct answer will be option B, that is energy gap in germanium is smaller than in silicon. Now as we know, energy band gap of a crystal is basically a function of interatomic space. Means lower the energy band gap, higher will be the carrier concentration. So its correct answer will be option B, that is energy gap in germanium is smaller than in silicon. Now the next one is that is an electron device means the device in which the conduction of electron takes place through. Option A is a gas. Option B is vacuum. Option C is a semiconductor. Option D is a gas, semiconductor or vacuum. Its correct answer will be option D, that is a gas, semiconductor or vacuum. Now friends, that's all. Thank you.